In this question, for which one of the following functions is the equation the absolute value of f of x plus y minus f of x minus y equal to 4 square root of f of x times f of y true for all x and y elements of R? So in other words, which one of these will satisfy this equation here? So starting with equation A, or answer A, f of x equals x squared, and writing that down here, f of x equals x squared. So all you have to do is do this equation by using this function here, f of x equals x squared. And so starting with the absolute value of f of x plus y, that's replacing the x in here with x plus y. So that becomes x plus y in a bracket squared, and then minus, and then do the same with this. So replace the x in here with x minus y squared, and then that may or may not be equal to 4 times the square root of f of x, which is x squared, and f of y, which is y squared. So those two multiply together like that. And then the next step is to expand the brackets. So you end up with x squared plus 2x y plus y squared, and then minus in brackets x squared minus 2xy plus y squared, and that's equal to 4 square root of x squared y squared. And then what you can do from here, the x squared terms cancel out, so x squared minus x squared equals 0, and y squared minus y squared, so those two terms cancel each other out, and then you're left with 2xy minus minus 2xy, which is 4xy, and the absolute value of that. So is that equal to 4 times the square root of x squared y squared? So this means, well, the value of this is going to be 4 times x times y, and if x or y, or x or y are negative numbers, then all of that will be negative, and then the absolute value will make the answer positive. Here, this would become 4 multiplied by the square root of x squared is x, and the square root of y squared is y. So when you, and it's the positive square root here, there's no minus sign in the front here, so you're taking the positive square root. So even if x is a negative number, for example minus 7 squared, and then it would equal 49, and then the square root of that, you could say, well, that's minus 7, but you want the positive square root, so you'd be taking 7 as the square root of that 49. And so because you want the positive square root, whatever numbers go in here, when they're squared, they become positive numbers, and then the square root of that, the answer will be a positive number. So this is going to be positive no matter what, according to this, and this is going to be positive also. So on this side 4xy, and on this side 4xy. So two identical expressions, so they are definitely equal to each other for all values of x and y being an element of all reals. And that's what you're trying to do with all of these equations. Find out which one ends up being something equals something, and they're two identical expressions. And as it happens, this one is in fact the answer, the correct answer. So it's good practice to go through and practice all of these so you can deal with this kind of question with different things, because next time they might put the correct answer at the bottom and you'd have to go through all of them. And it could also be a short answer question. So I'm going to go through the other parts. So A is the answer, and I'm going to look at B next. And in B, the function is the absolute value of 2x. So applying this rule or equation to this function, so it becomes, so f of x plus y, again replacing the x with x plus y, so you get the absolute value on the outside with the absolute value of 2 bracket x plus y, and then minus f of x minus y, so that would be the absolute value of 2 bracket x minus y, and then that may or may not be equal to 4 times the square root of f of x, which is absolute value of 2x, multiplied by f of y, which would be the absolute value of 2y. And that's the absolute value on the outside. And then really from here you could say, well, you could do this, you could multiply the brackets out. It's not going to really do much, so the absolute value of 2x plus 2y minus the absolute value of 2x, and then minus 2y, and 4 multiplied by, so the absolute value of 2x is just making sure that's going to be positive, and the same with this, making sure that 2y is going to be positive. So 2 times 2 is 4, and x times y, you can actually do this. So the absolute value of something times the absolute value of something else is the absolute value of the two things times together. So again, that's just making that positive. You could take this 4 out the front and it would equal 4 times 2, which is 8, square root the absolute value of x, y. So here you've got the product of x and y, and then taking the square root of it, and then over here you've got a sum of 2 times x and y minus the difference of 2x and 2y. And so there may be some x and y values that will make this equation true. In other words, if you put some x and y values into here, and one number that will work is 0, 0 for x and 0 for y, this will become 0 and this will also become 0. So it's actually true for x equals 0. There may be other numbers that will also make it true, but not all values of x and y will make this statement true. So for that reason, B is not the answer. And again, ideally you're looking for two expressions that are identical, and I don't think there's any way that you can make this look like this. So that's part B. So part C, f of x equals e to the x, and then this equation will become the absolute value of, again, replacing the x with x plus y, you get e to the x plus y minus e to the x minus y. That's better. And then equals 4 square root. So f of x is just e to the x. F of y is e to the y. And is there any way I can make this identical to this expression? Not really likely at all. You have a product of two things, and here you've got something minus something. So I'll have a bit of a play around with it. So this, when you have the addition of powers up here, that's really the same as this expression here. So when you are multiplying two things and they have the same base, you always add the powers. So if you had this, then that would be what result you would get. So this is just going from here in the opposite direction, and then you would have something similar here, e to the x multiplied by e to the minus y, and then that would equal, it's equal to that. There's not a lot I can do with this really here. Maybe go e to the, that could be x plus y. Again, because you're multiplying, you would add the powers, and then the square root of all of that is to the power 1/2. And then here, about the only thing you can really do here is take out a common factor of e to the x. So e to the x bracket e to the y minus e to the minus y. That's not really helping the situation. I don't think I'm going to end up with this at all. In fact, I'm fairly certain. So e to the x plus y to the 1/2. And again, for some values of x and y, this may be true, but not for all values of x and y. I'm pretty sure there's no way of changing this into this expression. So I would say based on that, that if I was doing this in an exam and I would stop here and try the other options kind of thing. So now onto the last two parts, D and E. Part D, f of x equals x cubed. So applying this equation to that function, it becomes the absolute value of, and replacing the x with x plus y, you get x plus y cubed minus x minus y cubed, absolute value sign bracket, whatever it's called. And then for f of x is x cubed, and then f of y would be y cubed. So here you've got the difference of two cubes, and the rule for factorizing that, so that's a cubed minus b cubed equals a minus b in that first bracket, and then all positives for the second bracket, so a squared plus ab plus b squared. And applying that rule to this, and see what happens. So it's going to be the two brackets added together to start with, or actually subtracted. It's x minus y minus x minus y according to this bracket here. And that I'll put in a square bracket, and then the big bracket, a squared, so this thing squared, x plus y squared, and then plus ab, so that bracket times that bracket, so x plus y times x minus y, and then last of all the last bracket squared, so x minus y squared, and the square bracket, and then the absolute value sign, and equal to 4x cubed y cubed. And we'll see what happens. So x minus x, they cancel out, and then y minus minus y is 2y, then big bracket, expanding this, x squared plus 2x plus y squared, and then this is the factorization of the difference of perfect squares. So this, if you multiply that out, you will get plus x squared minus y squared, and that's the difference of perfect squares. And then the last bracket expanded, x squared minus 2xy, and then plus y squared, and then square bracket, absolute value sign, and then the 4x cubed y cubed under the square root, and then absolute value of 2y, and then this is going to become, so x squared plus x squared plus x squared, 3x squared, and then y squared minus y squared, so those two cancel, and then you're left with 1y squared plus y squared, and then what else is there? That was supposed to be 2xy. I think I said it but didn't write it. Alright, so this was 2xy minus 2xy, so those two cancel. And just to be sure, x squared, x squared, x squared, 3x squared plus y squared. Alright, so that's what that simplifies to. And over here, 4 square root of x cubed y cubed. Now, again, I don't think that I can turn this somehow into this. In fact, I'm pretty sure. Therefore, based on that, x cubed doesn't satisfy this equation, so therefore D is not the answer for this, the correct answer of the 5 options. So moving on to E. Okay, so here's part E, f of x equals x, and applying this equation to that function, you would have absolute value of, so this would just become x plus y, and then minus in brackets x minus y, which is equal to 4, and then under here you'd have f of x is x and f of y is y. So x minus x, the x's cancel out here, and then y minus minus y is 2y. So the absolute value of 2y equals 4 square root x and y. So you would really need to have an x somewhere in this expression here for this to be able to be changed or rearranged to look like this. Not possible because there's no x on this side. So I would say it's definitely not possible. So for some x and y values, this would be true. This which would make this true for some values of x and y, but it has to be for all values of x and y from the set of real numbers. So this function doesn't satisfy that for that condition of x and y being an element of R. And so E is definitely not the answer. A is the answer A. And once again, it's good practice to practice all the options in this type of question when you are preparing for your final exams or just doing the questions during the year. So that's it for this question, and I'll see you in the next one.